Do you see applications for colleagues here in the area to be able to use this type of technology as well?
I know in Europe they're 3D printing satellites. There's a company that's 3D printing parts of components on airplanes, which have higher standards than just something you would print from the ground. So if it's good enough for the aerospace industry, we're going to be 3D printing or additive manufacturing many items. I feel like I'm on a mission to promote this because a lot of people here aren't aware that you can even 3D print in things other than PLA, which is really low grade. Very cheap, very easy, good. It's really good for 3D printing because it goes from a liquid to solid very quickly. The glass transition temperature is very sharp. So it's very good to print, it's very solid, it doesn't have a lot of sagging, it's safe, it's made out of cornstarch, it's a renewable resource, but it's pretty fragile. It's not good for any working components. Okay? So a lot of people think that's all there is. They think these are toys. That's not true. And so we can make things that we can actually use in the lab for prototyping, that you can actually cinch things down and actually have some forces in there known, to ultimately flying them in space. Now that's a little bit more down the road, and there's still things that need to be proven how strong these are. If you take something that's machined, a billet material, when you buy it from a company, they tell you exactly all the mechanical properties of it. When you take a material and additively manufacture it, that changes because there's voids and layers and air gaps. So there still needs to be a lot more analysis done for different companies and materials, how strong they are. But the ability to do them, they're there. As far as in the lab here, not just the prototype ideas and change things. And nowadays you can do it all on a computer and modify it and print out something really quick and cheap like this, for 13 cents, to get a feel for it, and even maybe some mating before you actually have a machine shop making it be expensive. But also along those lines is, besides actually just making something, the picture's worth 1,000 words. Well, a solid model must be worth 1,000,000 then. When you conceive of ideas and instruments and whatnot, usually it's a nice PowerPoint presentation and pictures, and you show data, previous instruments, heritage, where we got this from. To actually print something out and let someone hold it in their hand really helps people get a feel, and it's really good for promoting new ideas, if that makes sense. Better than a picture.
I think you brought something along that shows some of that mating. Would you be able to show us that?
These are...
The rocket.
Oh, so this was something, I worked on the sounding rocket program. It's a fancy name for suborbital rockets. NASA and the Navy have been doing this since the 50s. This is an actual scale model I got from detailed mechanical drawings from our sounding rocket program. I use it because I think it looks really cool in my office, but also I use it for education and showing people what works out there. So I learned a lot about SolidWorks and 3D printing because I could not take just a really detailed mechanical model and print it. The details are too fine, there's a lot of hollow voids, so I learned a lot about things that may already be out there, a solid model in the world, doesn't mean you can print it. So that's a learning curve for me and for everyone else, and we want to try to get everyone involved to understand that when you make a model, when you create a model, or when you output it or make it available on the web for people to download and print, not everything is printable. And in the case of this, the scale of this is about 17 inches across and only 1/4 inch thick. So trying to print that at this scale, it would be, like a sheet of paper. You can't print a sheet of paper thickness. So, but I also with this, it demonstrated what a sounding rocket mission does, which is very much just like a model rocket program if you ever did model rockets as a kid or as an adult. I also made this so that I could break it down what happens during a flight with kids. So this is a 2-stage Black Brant rocket. So the booster here is a Terrier booster. It burns for about 4 seconds, falls away. And then the Black Brant burns for about 30 seconds. It falls away. Nose cone pops off. There's a magnetometer in here that helps align with the Earth's magnetic field. Basically, it flips over, a door opens up, and then in the case of this mission, which looks at the sun and extreme ultraviolet light, lasts about 6 minutes worth of data, and then the whole process reverses, turns back down, falls down to Earth, and about 2 miles up, a parachute opens up, just like a model rocket, and we get a helicopter fly out in the desert and get it.